In Telenor R&I, we participate in the SNSJU project called Imagine-B5G. We help open call entrepreneurs such as Fametrics to test and validate their applications and devices in our advanced 5G platform.
Today's factories rely on rigid hardware-bound PLCs, expensive to scale, locked to the specific vendors, and hard to update. This inflexible setup blocks innovation from real-time AI to predictive maintenance. With Pulse 5G, we are exploring the future of PLC as a service, a cloud-native control concept enhanced by ultra-low latency 5G. Simtera's Fametrics platform aims to virtualize PLCs, enabling real-time AI-driven decisions while reducing machine-side processing and infrastructure costs. This is the setup for our PLC as a service application. We use two sensors and small motors to generate and measure vibrations. A soft PLC functioning as an edge device collects and processes sensor data. An edge device, which is gateway, connected to a 5G network, and it serves as a primary interface, transmitting data to cloud. And in the cloud, our AI model processes the data and sends result back to the motor machine. During this phase, we measure the end-to-end latency and provide feedback to the machine or motor regarding to the process status. End-to-end latency was evaluated across three network infrastructures. 5G demonstrated more consistent performance with lower packet loss and stable latency. In contrast, ADSL and cable experience higher packet loss and greater fluctuations, caused by bandwidth limitation and jitter. Our solution helps manufacturers cut down time, reduce energy waste, and bring AI to shop floor, even for SMEs. For OEMs, it enables remote configurability, faster deployment, and new service-based business models.
Latency is crucial. Our advanced experimental 5G lab supports Fametrics with a private network for this purpose.
Pulse 5G shows how advanced 5G connectivity enables smart, scalable, and sustainable industrial automation. Let's shape the future of manufacturing together.
Rehabilitation and agility training can be challenging, especially when expert guidance isn't available and on-site for real-time feedback and diagnostics. Introducing 5G4 an Imagine-B5G Open Call 3 vertical experiment by Nisatech that combines 5G connectivity, AR technologies, and biomechanical tracking for e-health. This next-generation tool lets trainers perform real-time agility tests remotely. The trainee receives visual commands in AR glasses for change of direction, or COD, which should be followed promptly. Using motion X-rays technology, accurate data on the trainee's COD is calculated and analyzed instantly. Based on results of previous COD step, trainers can initiate dynamic agility tests, guiding the trainee step by step for personalized agility training or rehabilitation. The system combines a smartphone Smart4 Fit app and Polar Verity Sense sensor. Data is pre-processed on the app, sent to the cloud for calculation of biomechanics and COD, and displayed in real time for the trainer. We compare 5G with 4G and Wi-Fi and explore telco cloud deployment for better latency and privacy. 5G delivers significantly lower and more consistent round-trip times than 4G and Wi-Fi, enabling real-time feedback and elevating the overall experience for both trainees and trainers. Moreover, agility training is no longer confined to a single space. Whether indoors, outdoors, or remote, personalized training and rehabilitation can happen anywhere without compromise. This trial took place at the Imagine-B5G Norwegian Facility, hosted by Telenor at Fornebu, Norway. 5G4 bringing agility, training, and rehabilitation into the future.
via Imagine Open Call 3, we at Telenor hosted Project Scanner at our Beyond 5G test facility. Scanner, which is a FinWeb product, explores novel methods for remote inspection of industrial components.
Scanner combines micrometer-level 3D scanning, extended reality, robotics, and 5G to improve industrial component inspections. Instead of relying on traditional visual checks, we create digital twins that can be inspected and measured remotely in XR. Here, users interact with high-precision point clouds, identify defects, and collaborate in real time through 5G connectivity.
Together with our partners, Telenor provides Beyond 5G networks that are already transforming how industries inspect, innovate, and evolve.
Hi, I'm Sebastian Rust, a PhD student at the Technical University of Darmstadt. For the past few months, I've been working on 5G PACE, part of the Imagine-B5G project in close cooperation with the Norwegian Facility in Oslo. Here's the challenge that we're tackling. Video editors usually have to be on-site at the source. That makes production slow, expensive, and sometimes even risky. Here's the solution: remote multimedia production. It lets editors work from anywhere, which is faster, cheaper, and safer. And at 5G PACE, we are taking that process to the next level. So, how does it work? Well, let me show you.
In this workflow, video data travels directly from the camera on set into the 5G network, then passes through the general internet before reaching the editor's workstation. For remote editing to succeed, two conditions are essential: low latency and high-quality video streams. Without them, editors cannot make quick, accurate decisions, and the entire workflow is disrupted. A video is just a rapid sequence of still images. At high speed, our visual system perceives smooth motion, but stuttering disrupts the effect and feels unpleasant. At the network level, every few milliseconds a new pile of data is created. And as video quality improves, those piles only get bigger. All that data wants to be transmitted instantly. If all that data is sent in sudden bursts, the network struggles. Latency increases, video stutters, and decision-making slows down. That's where 5G PACE comes in. By spacing out the packets over time, the network handles the load more smoothly. Latency drops, and image quality improves. With support from our partners in the Imagine-B5G project and the Norwegian Facility in Oslo, we deployed hardware-based pacing in modern, high-speed 5G networks to achieve precise timing needed for effective pacing. Across 2 experiments, we demonstrated that pacing reduces overall network stress and minimizes stuttering in high-bandwidth video streams. However, limitations in the hardware we used prevented pacing from showing its full potential. Nevertheless, the results indicate overall positive effects of pacing, and we remain confident in its strong potential that with pacing, remote video editing becomes faster, smoother, and more reliable, helping creators focus on what really matters: the story they want to tell.